Hello, MBA students. I hope everybody's having a good evening. Just a fair warning, I do have my children with me tonight, so if you happen to hear some sweet little voices in the background, that is them. So I apologize if they interrupt, but they might. All right, so here's what we are going to do. I am going to show you how to do this worker scheduling model in Excel. So let's start by naming our ranges. We are going to grab the employees available and the employees required and go to formulas and create from selection. Again, it should create the name from the left column. We're going to grab the total employees and create from selection. Now we are also going to grab B4 through B10, which is the number of employees that are starting each day. However, we have got to define the name because that name is not in the cell above them. So we're going to call that employees starting, just like it is in your text. And if you're following along in the text, we are on, this is the problem that starts on page 146 and 147. All right, so I'm going to go ahead and copy and paste these names. There we go. All right, and let's go ahead and highlight our decision variable. So our decision variable here is going to be what day the employee starts, and then highlight that, and then per the problem, whatever day the employee starts, they work the next 4 days. So they work 5 days in a row. So if they start on Monday, they work through Friday. If they start on Tuesday, they work through Saturday. If they start on Wednesday, they work through Sunday, etc. So the first thing that we are going to do here is we are going to have to link this grid to our decision variables. So again, we know if the employee starts on Monday, they work Monday through Friday. So these employees that have started on Monday are going to all come from this cell. Okay. All right. And what I did to get that all to go in at once is this. Okay, you are going to highlight cells C15 through G15 because if the employee starts on Tuesday, we know they work Tuesday through Saturday. And then we are going to go up and enter in the cell for the employees who start on Tuesday, make it an absolute value, and then you press Control, Shift, Enter, and it will input that formula or that cell reference into all of them at one time. So we can go ahead and finish the rest of them. So if they start on Wednesday, they work Wednesday through Sunday. So we select Wednesday and make that an absolute value, and then Control, Shift, Enter. Here's where it gets a little bit more interesting. If they start on Thursday, they work Thursday, Friday, Saturday, and then Sunday, and then they go and work, and then they work on Monday as well. Okay, so you have to wrap around. Did that grab it? I think it did. If not, we will. Yeah, it looks like it did. Okay, so starting on Thursday, and again, absolute value, and then Control, Shift, Enter, and it didn't get the rest of them. It's okay. Copy, and we'll just paste it. Okay. All right. And again, if they start on Friday, they work Friday through Tuesday. It's not working real well to have it separated, but that's okay. All right. We can also do it like this easily enough. Equals Saturday absolute value and drag it all the way across. Any way you want to do this will work. I pick the one that you like the best and works best for you. There we go. So what I did that time, I put it in, put the number in, put it as an absolute value, and then I drag it all the way across, and then I took out the ones that it should not be in. All right, so then they start on Sunday. They start on Sunday. They're going to work every day except Friday and Saturday, so I'll fill it all the way across, and then take out Friday and Saturday. Now, we have to sum the number of employees that are working every day. We do that by going B14 to B20. In the first cell, no absolute values because you want that to go all the way across. And then we are going to grab the total number of employees. Now you have to grab the total number of employees from your decision variables up at the top, okay? Because an employee will only start on one day of the week. If you have an employee that starts on Monday, they are not going to also start on Tuesday. They will work on Tuesday, but that's not going to be the day of the week that they start. All right, so now we can go ahead and run Solver. All of our variables in, and our constraints for the, our objective cell is B28. Now my template is saying that that's the cell to maximize. You don't want to maximize that cell. You're actually trying to minimize that cell. Employees cost money, and so the business is trying to see how many they have to have. They don't necessarily want to have extra. How many they have to have in order to meet the demand. They may have some extras on a given day in order to make other days work, but they are trying to keep their employees to a minimum to contain costs. All right. So B20 is our objective cell. We're setting it to a minimum, and we're going to do that by changing the cells in our decision variables. So that's B4 to B10. You can also type in the employees starting if you prefer to do it that way. Now we need to add our constraint. We only have one constraint in the problem, and that is that the employees available on any given day must be greater than or equal to the employees required. Our other constraint was that once they started, they had to work the next 4 days in a row. We dealt with by using this chart rather than putting it into the actual constraints of Solver. So we can go ahead and click OK and make sure that you're running Simplex LP and do solve. Okay. All right, we're going to go ahead and keep the Solver solution, and I want you to notice it looks like all of these are whole numbers, but they're actually not. I'm going to change this so that it shows you decimal places. Okay. And see how it is scheduling partial employees to work on Sundays. How well does it work to schedule a 6.3 employees to start on Monday? Can you have a partial employee? No, of course not. And so this is not really a feasible solution unless we put in an integer constraint. So that is the next thing that we are going to do. So you go back to Solver, your model is still there, you just simply add a constraint. We select our decision variables, and we put in a constraint that they have to be integers. And okay, tell it to solve again. And now we have employees that we can actually schedule. We can schedule 6 employees, we can schedule 3 employees, we just cannot schedule 6.3 employees on any given day. I want you to notice something, that before we put in the integer constraints, we could have gotten by with 22 and a third employee. Now that we have the integer constraint, we have to have 23 employees. That's something to note about modeling, is that you can never improve the outcome of the model by adding constraints. But that does not mean that you want to just take out all constraints and let the model do whatever they want. You've got to get it as close to reality as you can, or the model won't end up doing any good. So If you come back in an actual business situation with a model that's unfeasible or way out of bounds, you can start looking at the constraints and going, well, what could we actually change to get this closer to where we want it? You can't just start randomly pulling out constraints and expect that you'll make it work in the real world. You may not. You've got to think through the constraint. Is it something I can change? Is it feasible to change? Is it cost effective to change, etc.? Under no conditions could you ever schedule 6.3 employees given these constraints. What you might be able to do is hire some part-time employees to fill in those gaps. So that's just one example of some things that you might be able to go back and maybe do differently. Maybe you can, maybe you can't. It's going to depend on the actual business situation that you find yourself in. All right. I hope that this has proved useful for you. You do have one of your homework problems that is similar, and I believe that is going to be, I believe you have problem 46 that's going to be similar to this one. It's not exactly the same, but it does have some similarities, so you can use this as a starting point for that problem. As always, if you have any questions, please email me, call me. I am happy to help you. I do want you to try this first, but if you have tried for a while and have gotten frustrated, reach out to me. I'm glad to help you. Hope you have a good evening.